Okay, we're going to do some review problems from section 1.1 and section 1.2. We'll start with a fairly simple Algebra 1 problem. Solve 4 minus the quantity 3 minus 2x equals 5x minus 2. So you're going to have to remove parentheses, gather like terms, get everything on one side, and solve for x. So try this and come back, check your answer. So when we remove parentheses, it turns into 4 minus 3 plus 2x on the left side. Combine like terms. Then add 2x's, or subtract 2x's from both sides and add 2 to both sides. And we end up with a very simple equation, 3 equals 3x, which by inspection, we just see the answer is x equal 1, which we can plug back in and find that it does indeed work. The next problem I want to look at is this equation with the fractions. 1/3 times the quantity x minus 2 minus 1/4 times the quantity x plus 5 equals a half. And we could work with this equation with all these fractions, but it ends up being a lot of work finding common denominators. The best way to solve this is to clear all those fractions, and you do that by multiplying both sides by the least common denominator. And by doing that, you'll get rid of all those fractions, and then you'll have a real nice simple equation to solve. So try that. So when you multiply both sides by the least common denominator, which in this case is 12, and you distribute, on the left side you end up with 12/3 times x minus 2 minus 12/4 times x plus 5. On the right side you get 12/2. And that simplifies to this equation, 4 times quantity x minus 2 minus 3 times the quantity x plus 5 equals 6. So now you just distribute, combine like terms, and solve, and it ends up being a fairly simple problem. So you get 4x minus 8 minus 3x. Remember, it's minus 3 times 5, so it's minus 15, not plus 15, equals 6. Combine like terms, x minus 23 equals 6, so x has to equal 29. Okay, in the next problem, we have a linear equation that has not only fractions in it, but decimals. And here, you've got double the trouble here working with it, but we can get rid of both the decimals and the fractions in a similar manner as we did in the last problem, multiplying both sides by the correct number that will eliminate both the decimals and fractions. Well, we can get rid of the decimals by multiplying both sides by 100, because that's going to move the decimal point 2 places on both of these decimals. But multiplying by 100 will also clear out the fractions. So do that and then solve this problem. So when you multiply through by 100 and distribute, the 0.03x turns into 3x. The x minus 1 over 5 turns into 20 times x minus 1. Because the 105 cancel to give you 20. The 0.25x turns to 25x, and 100 times 1/100th, the hundreds cancel, leaving 1. So again, we get this nice simple equation to solve, and we just distribute correctly and then move all the terms to one side and solve. So when we get all our x's on one side and all our numbers on the other side, by adding and subtracting to both sides, we get negative 19 equal 2x. So x equals negative 19/2. Okay, one more problem with these fractions, and by now you should be good at doing this. This problem should be pretty easy because it's actually easier than the last one we did. So solve this linear equation by clearing fractions, come back, check your answer. So multiply both sides by 12, and the equation simplifies to 12/4 x, or 3x, 12/3 times x minus 2, or 4 times the quantity x minus 2. Don't forget those parentheses. And 1/2 times the 12 makes 6. So then we just distribute, combine like terms, add the 8 to both sides, and we have 7x equals 14, so x equals 2. Again, it becomes a very simple problem once we clear the fractions. Okay, our last problem for 1.1 review. This is a WebAssign problem. The gas mileage M of a car driving at a speed of s miles per hour is given as M equal -1/2 times absolute value s minus 55 plus 25. And the question I ask here is, what speed results in gas mileage M equals 24 miles per gallon? And this seems like kind of an odd equation with the absolute value bars, but it makes sense, because if you're going exactly 55, you're going to get the maximum gas mileage, because this whole factor will be 0. You'll get 25 miles to the gallon. But anything other than 55, you're going to be subtracting from the 25. And if you're going a little less than 55, you'll subtract. You're going a little bit more than 55, you'll subtract the same amount. So there's like a range around 25, and the absolute value accounts for that range, the two different speeds that will give you this gas mileage. So what you have to do here is plug in 24 for M and solve the absolute value equation. So we're going to solve this equation, 24 equal -1/2 times absolute value s minus 55 plus 25. Now, our first step here is we're going to want to isolate the absolute value. Once we do that, we solve our two cases. So to do that, we're going to subtract 25 from both sides, which would give us -1 equals -1/2 times absolute value s minus 55. Then multiply both sides by -2. So -2 times -1 equals -2 times -1/2 times absolute value s minus 55. So by doing that, the -2 cancels the -1/2. So we end up with the equation 2 equals absolute value s minus 55. So now we solve two cases. One where, so we have our two cases. One where s minus 55 equals +2, and the second case where s minus 55 equals -2. Well, those are pretty easy equations to solve just looking at them. In our first case, s is 57 miles per hour. In the second case, s is 53 miles per hour. So those are our two speeds that give us the 24 miles per gallon, and you can plug them in. 57 results in 2. -1/2 times 2 is -1 plus 25 is 24. 53 gives you -2, but the absolute value turns into +2 times -1/2 added to 25 makes 24. Okay, now let's look at some 1.2 review problems. This section deals with solving equations for a variable in terms of other variables. And the first equation we're going to solve is a equals p plus PRT for the variable P. This is like the simple interest formula from business. So we want to solve for the variable P. When you have multiple terms with your variable, you want to gather the terms together on one side and then factor out that variable. And that already our two terms are on one side alone. So we want to factor the P out. So we have A equals P times the quantity 1 plus RT. So now we can just apply algebraic operations to solve for P. Adding, subtracting, multiplying, dividing both sides. In this case, divide both sides by 1 plus RT. And we get P equals A over 1 plus RT. Okay, in our next problem, we're going to solve x equal y over z minus 2w for the variable w. Now, that w is in the denominator, and that's problematic here. So to fix that problem, multiply both sides by that denominator. So multiply both sides by z minus 2w. And that'll fix that problem. And then you can isolate w on the left side. So give that a try. So when you multiply by that denominator, you end up getting x times that z minus 2w. On the right side, the z minus 2w's cancel, leaving y. So now from there, you solve for w. Now there's multiple approaches here. You can distribute, but you don't have to. You could just divide both sides by x, then subtract z and divide to solve for w. That would be the way I would suggest, although it would not be incorrect to distribute and solve that way as well. So if we divide both sides by x, we get z minus 2w equals y over x. Then we subtract z from both sides, we get negative 2w equals y over x minus z. And then divide both sides by that negative 2. And we get this answer here on the right, and it's a little bit clunky, but it's correct, and I certainly would not mark it wrong on a test because it is the correct answer, but we can actually rewrite that a little bit more compactly. Since we're dividing by negative 2 is the same as negative 2 over 1. Remember, dividing by a fraction, invert and multiply, that's the same as multiplying by negative 1/2. So we can multiply that top part by negative 1/2. Negative 1/2 times the negative z makes positive z over 2. Negative 1/2 times y over x is negative y over 2x. So we get z over 2 minus y over 2x. And there's actually one more way we could write this. And the other way we could write this is take that z over 2 and multiply by x and x. So now they have a common denominator. So we get w equals zx minus y over that common denominator 2x. Now, that's the answer you would get if you would have distributed, and I show it down here if you want to look at it. If you were to distribute at this point and solve for w, you would get an answer looking a lot like that. So be aware there's different forms of the same answer for these problems, especially when you're doing WebAssign and they give you an answer different than yours. Check it over. Maybe you have the correct answer, it's just in a different form. For my paper and pencil homework, I will be looking at all the different forms, and if you have one of the correct forms, it will be marked correct. So don't worry about that. Okay, one last problem here. Solve x minus y equals z xw plus z for the variable x. Okay, and this goes back to the very first problem we did for this section, where you have multiple terms containing your variable. You'll want to get those together on one side and factor out that variable x. That's the only way you can solve this for x. So give that a try. Gather the x terms on one side, factor x out, and solve. So once we have all the x's on one side, or x terms, we have x minus xw. We added, that should be plus y, added y to both sides. So we have x minus xw equals z plus y. And now we just factor out our x. X times the quantity 1 minus w equals z plus y. Divide both sides by that quantity. So x equals z plus y over 1 minus w. Okay, and that's about it for the review for 1.1 and 1.2. Any questions, post them in discussions.